Hello everyone, today I'm going to be discussing with you some of the important data structures that you will need to know to clear your interviews. I've listed down some of the common data structures that we'll need to use. They are arrays, linked lists, hash maps, stacks and queues, trees and graphs. I'm going to be giving you an overview and let you understand what these data structures are. So let's start with what is a data structure. We can think of a data structure is nothing but how we will structure a data. That means when we have a group of data or a compound data, we'll need to arrange it in such a way that how we need it. There are many data types, each having its own advantages and disadvantages. So we will need to choose which data type most suits our needs. So without wasting much time, let us start with our first data type. That is arrays. So most of you might be already familiar with arrays. Arrays is a data structure that stores a collection of elements, and each element can be accessed by its identifying key called its index. Usually arrays are stored in a continuous memory. That means in our memory, that is our RAM, arrays are stored in a one continuous block. There are many advantages for arrays by using these methods. It is efficient for accessing elements. How you ask? Let me tell you. If we have an array, here it is 1, the next is 2, next is 3, next is 4, next is 5, next is 7. Some data are stored in a continuous memory block. We will know the address of the first block. Let the address be 100. Since arrays are continuous, if we want to access the index of the third element, we just need to add 3 memory spaces and we will be easily able to access that element. 1, 2, okay, third element is 1, 2, 3, this one. Third element will be this. So the advantage of array is it is efficient in accessing elements. It can be fast access of elements or finding elements. The second advantage is sequential storage. As the array's elements are stored in sequence in memory, it allows for easy traversal. We can traverse easily through these data structures and manipulate them easily. Now let's come to some of its disadvantages. I've told you that arrays are stored continuously. So due to this fixed size, we need to know the total amount that we need to spare for this array. Usually adding new elements to the end of the array might cause problems, as this is stored in a continuous memory while we are adding an extra memory here. This place might already be taken by some other thing. So adding elements might be a little difficult. So we'll need to as this place is not available, we will need to create a whole new array again. So that is one of the disadvantage of an array. And the next thing is insertion and deletion of an elements. So in arrays, if we want to insert an element here, there is already an element 5 here, and if I want to insert an element 6 here, the problem is with arrays it should be continuous. So first we need to shift every element to the right first, and then only we can add that element here. So for adding just one number, we need to shift the rest of the numbers to the side. Similarly, while deleting, if we want to delete the fifth, this element 5, we'll need to be pushing all the other elements from here to this side. So these are some of the disadvantages of an array. Now let's move on to our second data type, that is linked lists. You can think of a linked list as it is made up of different nodes. It doesn't need to be continuously stored as arrays. We can think of them as nodes like this. Each node contains a data and also a link or a pointer to the next element. That is, each node, this node can have a data called maybe 5, and this element is linked to the next by a pointer. A pointer will store the address of the next element, and this linked list can store another data, maybe 8, and this can be linked to the next with a pointer, and this is linked, this can store another data, maybe 7, and this is linked to the next, and this can store another data, 11, and the end of the list points to none. The end of the list points to none. And there is also one more thing. Each list has a head. Head is nothing but a pointer that points to the first element of the list. What is this? Linked list. So a linked list has a head. The head points to the address of the first node. And what is a node? A node is something that can store a data as well as have a pointer to the next. So this is a basic structure of a linked list. So now let's answer its advantages. The first advantage that we can see from array is that it can have a dynamic size. As it is not continuously stored, we can easily add another element to it by simply removing this pointer and pointing it to another node, and in this node we can add another different values, and you can make this point to none. So we can have dynamic size in linked list, and it is also very efficient in inserting or deleting elements. So let's try. If you want to delete this element, like we did in arrays, we don't need to shift every other element. We just need to change this pointer. We can shift this point, we can delete this pointer and add a new pointer to the next element. So this is removed. It is that easy. And if you want to insert a new element, if you want to insert back this 8, if you want to insert back this 8, it is simply by changing this pointer back again, changing one pointer here and changing one pointer here. So inserting and deleting is really easier in linked list compared to arrays. Then coming to the disadvantages, the disadvantage is that these linked lists will use much more memory than arrays. And there is also the issue of accessing each element. As linked list only contains the address of the first element, if you want to find the element 11, we need to travel the whole linked list. Like if we from head we have to go here, then from there we have to go to the 8, from there we have to go to the 7, and from there we have to go to the 11. As each node only knows the address of the next element, we'll need to traverse the whole way to reach elements. So random access, randomly accessing a middle element is really difficult in a linked list. These are some of the disadvantages of linked lists. Now let's come to the next data structure, that is hash maps. Now let me just erase these. So what are hash maps? Hash maps, or it is also called as hash tables, it is a data structure that stores values as keys and values. There is a key and there is a value. It stores them as keys and values. It uses a hash function. A hash function is a function that will compute an index for where the value is stored. So there is a key, maybe a key called India. You can store it like India, and it goes through a hash function and allocates a memory index, and where it will store its value. A value can be its capital, New Delhi. So it can store key value pairs like this. What it can be something else also, like it can have another key called student, and the student will go through a hash function and it will provide an index where we can store student's name. It can be, so a hash map stores values as key value pairs. In Python, we can easily identify hash maps as dictionaries. Dictionaries is a implementation of hash map in Python. It is already implemented in Python so that we don't need to create it ourselves. So now let's go into a little bit more detail and think of why hash map should be chosen. What are its advantages? First thing we can think is fast data retrieval. That is, we can easily retrieve the data we want from the keys. From our example, if we type the key student, we can quickly find the value, array value denoted with it in big O of a 1. That is, only one function is required and it is easily accessible. The next is dynamic size. That means there is, as hash tables are unordered, they can have dynamic size. That is, adding more data key value pairs to a hash map is really easy. And another advantage it has is efficient insertion and efficient insertion and deletion. We can efficiently insert and delete elements. Now let's go to some of its disadvantages. Its disadvantages include there is a large memory overhead. There is a large memory overhead when creating a hash map. And then there is something called memory collision. Let's understand what memory collision means. As I said, there is a key and then there is a value. This is key, and this can be val. Key and value is there. As I said, key is put into a hash function which will generate a index where value can be stored. But what happens if more than one key, if another key also found the index to be same, so no two values can be stored in the same index, therefore a memory collision might occur. So the programmer must create a proper hash value, a hash function, or do something that can efficiently tackle this challenge. Now that was hash map. That is all for this first part. On the next part, we will be talking about stacks and queues, trees and graphs. These are some of the more advanced data structures that you will need to learn. So thank you for listening to me, everybody, and goodbye.